So here's problem number 65. I'm going to do this problem wrong. All right? And then we're going to do the problem right. I'm going to make the mistake that we made. This, first of all, we're going to start with the translation of what it says. The velocity of a hovering gradient to right entering the interceptor is inversely proportional. Velocity is. Translating the words into symbols. Inversely proportional, which means the square root of s is on the bottom. But if there's a proportionality here, there's always a letter k, called the constant of proportionality. The translation of the first sentence of this is this notation. Velocity is inversely proportional to the square root of s. And whenever you see proportional, there's a constant of proportionality. Everyone good with that? Proportional to s, the number of kilometers from the Earth's center. Now, here's me doing this problem wrong. I take this and change this to, maybe I'll change this to s to the negative 1/2 power. And then I take the derivative of velocity, because that's acceleration, or so I've been told, and I get negative 1/2 k s to the negative 3/2 power. And I get negative k over 2, there's a constant of proportionality, over s to the 1 over s to the 3/2. And I'm told it should be inversely proportional to s squared. I'm told that this should equal to something, I'll use a new constant of proportionality, L, something that looks like that. And for the life of me, I can't reconcile these two. Those two are too different to be saying that they are the same. And there's me doing the problem wrong. Now, let me show you where our fatal mistake was. Our fatal mistake was here when we took the derivative of the velocity. I took the derivative of the velocity with respect to which variable? With respect to s. Because s was the variable that was in the equation. The change in velocity with respect to position is not acceleration. Acceleration is a change in velocity with respect to time. Right? What I have here is dvds. dvds. That's what I got out of this motion. But what I want is dv/dt. How does velocity change with respect to time? What might I multiply this by to get this? ds dt. Is that right? Symbolically, will that give us dv/dt, which is acceleration? Wait. What is ds/dt? Change in position with respect to time. This is velocity. So if I want to find out, okay, I'm going to take this part out. If I want to find out what acceleration is, I take the derivative with respect to distance, which is negative k over 2 times 1 over s to the 3/2 power, and I multiply it by velocity, and velocity is k over, I'll write it as k over 1/2. When I collect all my constant terms, I get negative k squared over 2, and I end up multiplying it by 1 over s to the 3/2 times s to the 1/2 is s squared. There's my new constant of proportionality. Acceleration is inversely proportional to s squared. Do you see how this looks like that other kind of the chain rule? Remember I said, for the most part, I don't use this. That's the exception. That's a tricky problem. Mostly because every time you see a position equation, you say, take a derivative, I get acceleration. No, you only get the acceleration when you take the derivative with respect to time. But we can get there using the chain rule. How are we feeling now? Better? Is it better get me a bucket?
Yeah.